So if you're not a physics guy or a math guy or both, you might want to skip this, but I'll keep this as simple. I'm sorry. Yeah. So I'll keep this as simple as it can be. So, yeah, I'm going to explain how Jarvis obeys the Newton's law of cooling and what the Newton's law of cooling is all about. So you might want to skip this 30 seconds if you're not interested in these stuff. So the Newton's law of cooling was Newton's way of trying to predict the rate of cooling of a body. So if you draw a graph of it, it's supposed to look like this. Temperature, I use that to denote temperature, and this is the time. So if a body is cooling, for example, this is 60, let's say that's 50, that's 40, that's 30, and that's 20, that's 25. So let's say currently the room temperature is 25. So if we plot, why did I write that? Very long. Okay, so if we plot a cooling curve, it will go like, so let's say 1, 2, 3, 4. It will go like this way. It will try to so yeah, once it's not a perfect curve, but it's supposed to look like this. So once it arrives nearly to the room temperature, it will start reducing its cooling rate till when it reaches the room temperature. So according to the principle of thermoequilibrium, everybody will try to, once everybody with different temperatures are put together, they'll try to reach this certain temperature equilibrium in which they all share. So this is how the Newton's law of cooling works. So Newton's law. I'm sorry, I didn't mention this at the beginning. So I'm currently at Wheaton College, which people here call Wheaton, which is written like this. They do not. I wonder why everyone is skipping that T there, but it's Wheaton College. They say Wheaton, which is located in Norton, and people here call it No, it's strange. Norton. I just said Norton, Massachusetts. I haven't had very many people say this, but I think I assume they'll be saying Massachusetts. Yeah, something like that. Okay, so Newton's law of cooling, actually. There are lots of Newton's law. So Newton's law of cooling. I'm just a high school physics guy, so it's not rocket science. So Newton's law of cooling says that the rate of cooling of a body is directly proportional to the temperature difference, provided that the temperature difference is small. Okay, so that's the law, and this is how it can be expressed mathematically. So d theta dt, I use theta to denote temperature, and d is like change in temperature. I use t to denote time. So d theta dt is varies very proportional to theta minus theta s. That's the temperature difference. That means the temperature of the body minus the temperature of the surrounding, the temperature difference. Because the temperature of the body is cooling, so it's reducing, so that will be a minus there. So it will be the d theta dt equals to a certain constant which you do not know, theta minus theta s. So yeah, let's do some integration, some calculus. Yep. So let me give a shout out to my high school maths teacher. His name is his name starts with a D. I'm not going to mention his name, but he used to know maths. It's almost like he knew everything in the maths world, like in the high school maths world. He was so obsessed with mathematics. He also taught me some part of computer science, like JavaScript. But he was so obsessed with mathematics, even his work changed. He used to work like the integral sign like this. I don't know what's that called in Greek, because it came from a Greek letter probably. So he used to work like that. He used to work like that. So he just knew his math. He was awesome. So d theta or theta minus theta s, I'll send this here. So it will be minus k dt. I'll integrate both sides and the limits here being to the final time from 0 and to the final temperature from the initial temperature. Okay, so integration on this side will give me something like this. Theta f, like the final temperature. These are the limits. So theta minus theta s equals to, this is a constant to move out, and dt will bring us t. So this will be expressed like this, since those are the limits. Theta final minus theta s minus ln of theta minus theta s. Theta is like the initial temperature of the body. Did I say that? I'm sorry. Okay. Theta is like the initial temperature of the body minus kt. So this can be expressed as theta f minus theta s over theta minus theta s equals to minus kt. But the natural log is log to base e. So log to base e, theta f minus theta s over theta minus theta s equals to minus kt. But this can be expressed as e power minus kt equals to theta f minus theta s over theta minus theta s. So Jarvis basically works in this equation right here. I've not finished it to the end, but what's left is algebra, like moving one thing to the other, moving the other to the other. So Jarvis obeys that law, and the approximate value of E is, it's like universal constant is almost 2.718, and some other characters there. Do you happen to remember them, Amy?
2.7182818.
2818. So he's a mastermind. He remembers that stuff.
I want to say that's right.
Yep. Like, yeah. So Wilton College is, I think it's one of the coolest colleges that I've been so far. I've been to MIT, I've been to Harvard, I've been to Brown. I've not studied there, like I've visited them. And Wilton College and University of Dar es Salaam. And yeah, I think those are the few that I can remember. And Mbeya University of Science and Technology. So I would say Wilton College is like a very cool university. It has this very cool makerspace, which I would call is the technological heaven for every high school kid out there who's inspired by Dexter, by Tony Stark, by Elon Musk. So shout out to my brother Sozo. Like I told you, he makes this cool, very cool stuff. So he made this tripod which I used to shoot this video. So the video that I was using to explain stuff in the board, we were using from this tripod. This part actually is 3D printed from stuff that and makerspace in Wheaton College. Wheaton College. And this also is 3D printed. And this is laser cut. Like a laser cutter is like this cool beam, like it's like Iron Man's technology. Oh yeah, Wheaton College has also got these NASA grade telescopes. They have like these 7 domes up there that, I think this is Area 51. Okay. Yeah, I think I've been to Area 51. So please be sure to subscribe, comment, like, and share. I wanted to start a fundraise for my channel, but I think sharing and subscribing will be more of help to me than fundraising and everything. Yo, my brother Sozo Maker just did this to me. I think I'm making sense right now. Maybe it's the only part that I made sense, but please be sure to subscribe and share and everything. So, see you next time. Do you have anybody you want to shout out, Sozo Maker?
No, you said it all.
No?
Nope.
Okay, I might cut that. I won't cut. I'll have to ask for his permission. So this is the Brainiac Sozo Maker that I've been talking about. That yes, he's always in here. He's the one who takes care of these stuffs and everything. So this is his workplace, his playground and everything. Yeah,
I live here basically.
yeah, he lives here. So please be. He has a YouTube channel, right?
Yeah.
I'll put a link in the description. Sozo Maker. He also has this website where he puts his cool stuff. He also helped me set up my website. So I'll put it global in a few minutes. And I also have this cool programming challenge. So if you have not followed me on Instagram, please do that now.
Oh, I gotta do that.
Yeah, that's the challenge. So I'll put that on Nathan Tech's Instagram and Nathan X. The Nathan X is my Instagram. So you might want to follow and everything. So yeah.
Alright, yeah, then come over to Sozo Maker. My website is sozomaker.com, and I have a bunch of cool videos, all tutorials, everything from start to finish, and I love to share, so come take a look. See you guys.